Hi guys, today we are going to determine if whether a number is a strong number or not. Okay. So how we are going to determine it. Okay. So let us check this number. Okay, 145. So if we extract the digits and if we calculate the factorial and if we submit a POF, so then it is going to result as the same number. So that is called the strong number. Okay. Suppose this 1 factorial plus 4 factorial plus 5 factorial, it is leading us to this particular 145. So both are same, right? So this is how we are going to make it right now. So these are the various steps I'm going to follow. So let me go step by step. Okay. So we are taking the input from the scanner class. Okay. Let us take one scanner class. Okay. Scanner class, which is going to take the input of that particular class. Okay. So I'm taking the scanner class and I'm adding this particular. So why we are using this one? So this is going to give us the number. Okay. So let me give some message. Okay. Let me give some message. Enter a number. Okay. Enter a number. So we are going to determine whether this is a strong number or not. Okay. So let me give it print and so se dot nesting. Okay. Se dot nesting. So let me write it. Okay. So this is the number. So which we will be inputting. Okay. So we'll be giving some number. So the very next step is, so whether we want to extract each digit. Okay. We want to extract each digit and then we will determine the factorial for that particular extracted digit. And then we are going to sum all the things. Okay. Sum all the digits factorial. Okay. So let us start that second step. So I'm going to use the value and for for the thing, like I'm going to store it in some temporary variable. Okay. And number is going to be stored in the temporary variable. So I'm taking the temporary variable. So if it is greater than 0 and I want to extract the one digit by digit, right? So how we can do that? Okay. So we are going to do that. Let me see. Yeah. So we are going to do that by modulus operation. Okay. So what we are going to do? So we are going to calculate the remainder or else like the extracted digit. Okay. Extracted digit by using the temp mod 10. Okay. This is what we are going to do. And so this is going to extract us. Let me write it. Okay. Extract the last digit. Okay. So we are extracting digit by digit. So that is what our expectation. And then so we should calculate the factorial. Okay. Let me write it. We should calculate the factorial of the extracted digit. Okay. So yeah, our number is here. So I need to what I need to do, I need to extract the factorial. Okay. So I'm going to do that by using one new method I'm going to create. Okay. So for calculating this, okay, yeah, this is going to be remainder, and I'm going to create one new method for calculating the factorial. Okay. For this number that we are extracting. Okay. So I created one new method. So I need to calculate the factorial for this. So here we can use the two ways. Okay. Two ways so that we can extract the factorial. So I can use the normal Java approach, Java 8 approach as well. Okay. Java 8 approach or Java 8 approach. Okay. Let me use the Java 8 approach first. Okay. So it will be very simple. So there is a interstream method is there. Yeah. Interstream interface is there. And there is a range function. So which is going to take that particular start to end. Okay. Start to end. So let me give the start and so range. There is a difference between the range and range closed. So if we give n plus 1, so it is going to calculate till n. Okay. So dot. So there is a reduce function is there. So our thing is rem remainder. So dot reduce. Okay, there is a reduce function in the Java 8. So where we will be going to give the function. Okay, so we need to multiply, right? So here if we thought about n1 comma n2, so we should multiply every time. Okay, n1 into n2. So every time we are going to get something. Okay, every time we are going to get something. Okay, so there is one. Okay, there is one error. So let me check. So what is error? Yeah, so error is removed. So let us check whether it is retrieving the factorial or not. Okay, so we are going to give one fact. Okay, so let me return that fact, or else directly we can give that a factorial. Okay, so we are going to give the factorial. So let me give it. Okay, so this is like private static int is a return type. So because we are going to retrieve the particular factorial of that number. Okay, so we got the factorial of that particular number. Okay, okay. So and every time we are going to sum this particular number. Okay, so every time the number is going to change. I mean, so I will mention. I will discuss you. So how this loop is working. Okay, let me take one sum. Okay, because so this sum is like I'm taking a 0 initially, because our scheme is like our whatever our aim is, right? So we need to extract each digit and we need to sum it up. Okay, that factorial we need to sum it. Okay, so that is the reason like I am using sum equals to sum plus calculate factorial of that particular thing, and then we need to uh, so we are extracting the each digit, right? I mean, so for the first time, so this temporary is going to have this 145. Okay, 145 more 10, it is going to retrieve us 5. Okay, so it is going to give us 5 for the first time, I mean first iteration. So again, in this calculate factorial, right? Calculate factorial, so it is going to calculate the 5 factorial. Okay, I need to sum the 5 factorial with again 4 factorial we need to get. So how we are going to get the 4 factorial? So there is a kind of thing, so we are doing like, so we need to do the division, so that we are going to get the 14. Okay, from the from this 145. Okay, so we are good, right? So what we are doing, so we are going to extract each digit by using modulus operation, and we are calculating the factorial for that particular number. And so right now it will be at the first iteration, it will be 5 factorial plus 0. Okay, okay, I'm doing iteration by iteration. Okay, yeah, I can mention the iteration number. Okay, this is the first iteration. First iteration, what will happen? So remainder will be 5. Okay, remainder will be 5, and sum will be 5 factorial plus 0. Okay, and what will happen to this one? Okay, what will happen? Temp will be, the temp will be 145 more 10. So it is going to give us 14. Okay, it is going to give us 14 because it is a integer, right? So not a factorial. Okay, it's not a what we can say, it's not a float number or decimal number. So that's why we are going to get 14. Okay, and in the second loop, so what it holds? Okay, so we will be checking. So what it will hold? So it will hold 14. 14 greater than 0, correct. 14 more 10. So in the second iteration, remainder equals to 14 more 10. So it is going to give us 4. Okay, in the second iteration, remainder will be 4, and it is going to calculate the 4 factorial. And so sum is already 5 factorial, that is 125, and 4 factorial is 24. So sum is like 125 plus 24. Okay, so this is 144 right now in the second iteration. Okay, the second iteration it is 144, and mention this as one first iteration. And so we will be having temp as 14, right? We will be having temp as 14. 14 divided by 10, what it will be? 14 divided by 10, so it will be 1. Okay, it will be 1. So in the second iteration, it will be 1. Okay. So this is temp. Okay. This is temp. So this is how it is going to work. Okay. So we are getting 1 and again 1 greater than 0, correct? And 1 factorial and 1 more 10. So 1 will be there. So for the next iteration, so remainder will be 1 and it is in the third iteration and it is going to add it to the sum equals to 144 plus 1. So this is going to be the third iteration. So we are going to get the 145. Okay. And here the temp variable will be updated to 1 more 10 and it is zero point 0.1, nothing but 0. So temp will be 0. So for the third iteration, okay. So this is how, okay, this is how it is looping. Okay, this is how it is looping. And so let us check. Okay, let us check whether it is retrieving the result or not. Okay, I'm going to calculate the sum. Okay, sum is holding 145. Okay, I'm putting one condition. Okay, this is a thought check. Okay, check the sum with the original number. So I do have the original number num. Okay, so I'm doing sum equals to num. So then we are going to print that as a Armstrong number. Sorry, strong number. Okay, so I'm going to print that out. Yeah, okay. I'm going to print that num plus is a strong number. Okay, that's it, guys. So let me run it. Okay, run as Java application. Okay, let us check. Enter a number. I'm going to give 145. Yeah, 145 is a strong number. Here you see. Yeah, and let me give some other number. Okay, let me rerun it and run as a Java application. And what is the number I can give? So 155. Okay, and it is not printing anything because we haven't put that else part. Okay, so that's the reason, like, it is not going to print anything. Okay, let me write it, not a strong number. Okay, 155. So it's not a strong number. That's it, guys. So if you have any questions, yeah, please